Hello, everyone. I'm here today to talk to you a little bit more about Webpack. So everyone here has already interacted with Webpack through our React applications. But what I wanted to do is really to share with you how to unlock the real force behind it. So let's start with the basics. What is Webpack? As you already know, we're using Webpack with our React applications because we want Webpack to use our module that have dependencies between each other and actually put them together and serve them as static assets for a browser to be able to render our applications. So in other words, we're basically using Webpack to bundle our front-end assets. What I wanted to note in this page is that Webpack doesn't only bundle JavaScript or CSS, which is what we're currently doing. But Webpack also bundles image files. So it could be your PNG, your JPEGs, and other languages as well, be it CoffeeScript, TypeScript, or anything else you're using. So let's look at the core principles. For Webpack, the core principles is we're looking at everything in our application can be a module. And when looking at the fact that we can make everything in our application as a module, we want to basically load only what we need as and when we need. Now, if you've noticed so far in our application, we basically have all of our files bundled together and served up as one bundle.js file, which is not the best practice ever, or not really a good practice, if I can say, because so far our applications are very, very small, and we don't really see the difference. But for very large application, the bundle.js file could go up to 10, 15 megabytes, which could take forever in loading from the network. So even just, this is what you see here is our bundles from Grace Shopper. And if you look at it, it's a very small application, and we already have 1.12 megabytes for our bundle.js file and 1.28 for the map. Now, just to convince you guys even more of how useful it is to really know how Webpack works, I want to talk a little bit more about a case study. I want to talk about Instagram. And the picture that you see here, the guy in the middle, his name is Pete Hunt. He used to work at Facebook, and he was managing, when Facebook acquired Instagram, he was managing Instagram Web. And this is words from Pete Hunt. He says Webpack is the only open source tool that does it correctly. And obviously, he's talking about module bundlers. So big stamp of endorsement from such a large application. If you look at Instagram, Pete Hunt is sharing that there's at least 17 entry points that Instagram has, even though when we browse it, we feel that it's only a one-page application. But there's actually 17 entry points. So in terms of business practice, they really needed a module bundler that will really help them bring the performance higher. So in 2014, the team was looking at bringing the efficiency to a higher level when loading images, because obviously consumers are very impatient and want everything instantly. So just out of the box, when they open Webpack and just use the basic module of Webpack, just bundling everything and serving up, they actually brought the page load of images from 250 milliseconds down to 120 milliseconds. That's 52% improvement, even without doing anything specific with Webpack. So this is just to show you how powerful it is. And one of the biggest case for using Webpack for the Instagram team is obviously it's a very visual application. So they have a ton of CSS classes defined. And as you know, CSS is defined globally, which creates a lot of issues. You probably have experienced that in your team. You might want to delete certain classes or add classes, but you never know when you're actually breaking something. And it's as easy as having one extra character in your CSS and you're actually breaking something. So the Instagram team actually is using Webpack and actually module bundlers what they want to do is they want to be able to write scoped CSS. So they're writing CSS for specific components, so in doing so, they can reuse the same class names, and they know for sure that there's not going to be any leaks to other components. So what that does as well is they could add new components, and it will not interfere with any other components in the system. That makes it so much easier when you have a big team of engineers and you have new people that are onboarding. They don't have to go through your entire CSS file. Right? They can go for a specific component and understanding exactly these are the styles that are applied to this component. And obviously, the best thing about splitting your CSS is to be able to do garbage collection. When we had all of our CSS globally, it was really hard to see, like our class.image, should I delete it? Should I not delete it? Is there anything in my application using it? When splitting it, you know that if you delete a component, you can just delete the whole thing out. So that's kind of like the main reason why Instagram was so happy with using Webpack, and I want to deep dive a little bit more in our config file and how to make Webpack powerful for your capstone project. So in looking at, this is sort of like the basic configuration or structure of the config file. So as you can see, there's an entry, there's an output, there's, if you see on the left-hand side, there's a module, and then there's a plugin area where you can put your conditions. So I want to go into a little bit more details about these four key concepts. What you have on the right-hand side is actually an example of config file where you have multiple entry points. So you actually have 2 entry points, even though the entry is ./example for both the cases, but you have the first one's names is mobile and the second one is desktop. So you can actually generate 2 different bundle.js files for each of the entry points. So let's look at the key concepts. So we are already familiar with entry and output. Let's look at loaders. Loaders are essentially working on the individual file, and they would amend before or during the process of generating the bundles. Plugin would actually look at the chunk level, and by chunk we mean the whole chunk of code related to your entry point, and it could modify the way we're doing it as well. So if we look at the entry points, there's 3 types of entry types that we can look at. If you're only using one entry point, you can use any of the 3 types, whether it's string, arrays, or object. What I want to focus as is the last one, which is when you have a real multi-page application, you do want to use an object so that you can have, if you see the example, we have 2 entry points and the output file name, you can actually just do brackets name.js. What that will do is that will pick up the name of the entry, and it will generate 2 different files for the bundles. Which brings us to talking about output placeholders. These are the different placeholders that you can use. Path, of course, would return the entry path, the name as the entry name. Now, the last 2 are the most interesting, so hash and chunk hash. They will return a hash number to make it unique, and I'll give you an example. So if we look at the example here, which is used for long-term caching. And the reason why we're looking into long-term caching is because every time we update something in our application, our code needs to be redeployed to their server, and it needs to be re-downloaded by all of our clients. It's quite inefficient when you have your entire application re-downloaded, right? So browsers do cache already static resources, but when you do change these static resources without changing the file name, your browser would not actually realize that it's a new file because it's the same name. So chances are your clients are actually still seeing the old file, the cached version of your file. So the easiest way to go around this is, of course, to update the file name of your bundle or of your static assets. The only thing is you don't want to have to do that manually and keep track of what version you're at. And that's why we're using this here. If you look at the file name, you have your name.hash.js. What that will generate is if you look in the middle, a hash number that is added to your file to make it unique. Now, there's also a problem with this, because with every new build, all of your files will get a hash number. If you look at it here, we only have one condition, which is to add the hash after the name. So all of our file will get the hash number in the file name, and the browser will think that all of our files are updated, and will, again, re-download everything and re-update everything, which is a problem we don't want to have as well. So which brings me to the last one of the output placeholders, which is chunk hash. What chunk hash will do is it will be specific to the entry chunks, and it will only update the chunks that have been updated. So I can give you an example after this. But just a side note on this is you don't want to use chunk hash or hash when you do development, because you don't want to have to keep reloading everything while you're doing your development. You want to use that only in production, so that your browser knows when your files are updated. Let's quickly look at loaders. So this is an example of a loader. So our loader would help import, export different type files and change that into browser acceptable formats. If you look at this, this is an example in the config file. So this goes in the config file. Webpack will look for .css, because this is what we're looking for in the regex test. It will find .css files, we'll pass it to the loader. In the middle, you see an exclude, it will not look in the node module. And how loader works is it goes from right to left. So it'll pass to the CSS loader first, which is going to find the relevant CSS chunks that we're using, and will turn that into a JSON. And once that is done, it will pass to the next loader, which is the style loader. And what the style loader does is it will add the style tags on the text that we have, the CSS that we found, and serve that directly into our HTML. Now, if we don't want to have all of our style kind of just been plugged into our HTML, because then all of our clients can also inspect the page and get an insight on everything that we're writing, what we can do is use plugins. Now, plugins, this one specifically, the example that is here, is the extract text Webpack plugin. What this one does is it will use the CSS loader and the style loader to gather all CSS that we're using based on our dependencies, and pass that into our HTML. But what it'll do is it'll pass that as a style.css file, and it will serve the link to that file to our HTML. None of the code goes to the HTML. Now, because of time, I'm going to skip through this here. You guys will have reference to this later. This is just a summary of things you should look at for your capstone project when looking into how you can make it better with Webpack. Some of the most interesting things here is the CommonsChunkPlugin, which I highlighted. What this will do is it will automatically find the chunks of codes that you use commonly in multiple components, and it will bundle that in a separate bundle that is the Commons bundle. So you only load it once for all of your components. So if you go to a different page, it's the same component, it's already cached into your browser, and it'll just reload faster. So with this, use all of this, take the most of this, and just bundle it. Thank you.